And so let us get started um, for the linked list. Uh, so let me start with the linked list topic today. So let's in the linked list, what happens is like we have the different nodes. Nodes consist of, let's say, uh, three attributes. First is the previous attribute, second is the data, and third is the next attribute. So the next attribute specifies the next uh, next holder, data holder, and previous attribute specifies the previous data holder, whereas data specifies the actual data. So the representation of that can be seen like, let me go ahead and show you. So it would be like this. Okay, so it's a double linked list, but go ahead with the linked list first. So here what happens is, like, let's say this is the double linked list. Okay, so we need to open the linked list first. So here, okay, so this is the normal linked list. Okay, so let's consider we have the head and we have this is the head, the last is the tail, and uh, the next attributes specified in the last tail is null. Okay, so here what happens, this is the holder, data holder, and which we have the actual data as a, whereas the next attribute specifies the location for the second place, second holder, like second data holder, like b. So b's address will be saved in the this next attribute. Similar way, in the b's next attribute, c's address will be saved. Similar way, d's address will be saved in the next attribute of this third node. So this is the node, and these are the two attributes, that is the data and the next. And the first node is called as head, whereas the last node is called as tail. Similar way, we have the double linked list. The only difference is, like, we have the previous attribute here, which specifies the previous data holder or data node. Okay, like this, like b's previous attribute specifies on a node, whereas c's previous attribute specifies b node, like that. Okay, so let us start with the simple linked list here. Okay, let it be open. Okay, so here we need to look at the linked list first here. Okay, so let me start with the class for the node, let's say, and we need to specify the constructor here. So in the class node, let's say definition of new constructor. Okay, so inside it, let's say I'm taking self as well as I'm taking the data. Okay, yeah. So here self dot data equals to data, whereas self dot next equals to null. If you don't know about the structure of the class, why I'm specifying these constructor here, you can go to my previous video, which is for the properties of OOPS, and inside that I have mentioned clearly, like, what is the inheritance, what is the constructor, what is the self keyword, and everything is mentioned inside. The self keyword is just a representation for current whenever we are instantiating in an object that specifies, or that related to that particular instance of that particular, we can say, instance, the self keyword related to that particular instance. Okay, so here let me create another class, which is, let's say, link list. Okay, okay. So inside it, again, I need to mention the constructor. So So inside that I just need to specify some, because we just need self dot head is equals to head. So this head specifies the the first node. Okay, so let us get started. Okay, yeah, okay, so resume. After resuming, so here what happens, like after instantiating, or like after mentioning this constructor, we just need to go ahead and define a function to open the data, because we just need to open the data. Like let's say a b c d. First a, if a is inserted, then it will be the head. Whenever we want to open the data, it should go to the position of b. The third, whenever we are appending, we are trying to append c after b, it should go after b. So like that. So here inside class, the first attribute I need to mention is the self, to refer to the current specific instance of the class. Okay, so here uh, we just what we need here is like uh, so here whenever we are starting, we need something like let's say new node, because we just need the new node, right? Whenever we are specifying something, let's say append 1, then it should go to the new node, and we need data, but not only, not the specific data, we need to pass it through the class, so that all the attributes are assigned to them, like data is equals to data and next is equals to none, because right now we don't know what is the next address for the linked node. So here whenever we are specifying this, that means whenever the new data that is getting assigned to the new node. Okay, now this is the first step. Also we just need to specify something, like first we need to check, um, like let's say what we need to check is here, while let's say self, no, not self, I think here we need to check something like okay, let me see. Okay, so here whenever we are trying to insert a here, right? So we just need to make sure whether this head is present or not. So for that purpose, while so I think while will not work. We need to mention if not self dot head. Okay, this one, if this attribute is not there, then we need to pass we need to assign this self dot head with the new node. Okay, so what that means is whatever the mention in the inside the new node gets assigned to the self dot head, so it will be considered as this head. Okay, this will be the first step, and as soon as we did that, we just need to return or just get out of the specific function. So that's why I just return this return keyword. So next step would be, let's say whenever let's say like whenever we are instantiating the class, let's say like l is equals to ll, and after that whenever we are trying to open the data, let's say append 1, similar way l dot append, let's say 2, and l dot append 3. Okay, and we also need some other definition to display the data. So whenever we are appending the data 1 2 3 here, so this will work for 1, right? But whenever we are trying to append the second, this we need some other logic. So other logic would be like what, let's say we need something this new node, right? So here we need to check for we need to create the last node attribute, last node variable inside which we will be saving self.head. Okay, and we will be checking something like last node, while last node dot next. What that means is it will check for the next the last node's next attribute should be present. If it is present, then this will be true. Okay, if it is true, then the last node should be updated with the last node dot next, so that we can get the exact last node. And when we get the last node, okay, after we are getting the last node, okay, this is the last node, we just need to do something like we are trying to append, right? So append means what? Whenever we are getting this last node, we need to append the data. So we get the last node where the last and next attribute is null. So we need to do dot next, because we need to update this next attribute with the new node, so that it will make sure whatever we have mentioned is correctly being displayed. So here in append we also need data, right? Because we are passing the data here 1 2 3. Okay, so after display, inside the display we need current variable to store the let's say self.head, the first node, and we need to display it also. So we just need to specify condition like let's say while current something like current dot let's say data, and comma, and with something like okay this. Okay, and is it okay? Because we are checking for the current will be there, but we also need to change, because it will be remain inside this loop for infinite time. So to reduce that risk, we just need to update that attribute variable to let's say current dot next. So by this way what we are doing is we are specifying the next value with the current, so that it will take all the whatever the records are there. So let's see what it will display here. Okay, so head is not defined, so it is saying self.head, where it is saying line number 7. This is the linked list. Okay, self.head I have already defined. Okay, I need to mention this null right here. We don't mention this as a head. Okay, sorry. So if we run this again, it is saying yellow, the object has no attribute display. So I think there is some spelling mistake. Okay, display display. Now this should run. Okay, so it is running, right? 1 2 3. So like this it will work. So what if let's say I want to let's say insert or let's say like what if I want to prepend? We are appending the data till now, right? So what if I want to prepend? What I'm going to prepend is like, say we are appending the data like 1 after 2 is appended after 1, 3 is appended after 2. But what if I want something to be appended before 1? Is it possible? That is called prepend. Like let's say 5, then 1, then 2, and then 3. So that can be also possible. So how can I do this? Like let's say 5, then 1, then 2, then 3. It is also possible. So how can we prepend that data? So here let's say new node, similar way that we have specified. So new node is equals to going through the class node with the data as an attribute. Okay, so after this so let's say like we need to prepend, right? So prepend means we are replacing this head with something else, and this head will become the second node. So for that purpose, if I am inserting something here, let's say, okay, so, I'm inserting something here, okay, so I need to specify whatever the new node's next attribute to the self.head. So what we need here is, let's say, okay, after doing this, we just need to do something like okay, so let me think of it, like when we need, right? So we need to insert here. Okay, so let me try this way. New node dot next would be self dot head. So let us save self dot head somewhere. Okay, no, not possible. Okay, let's say it's self dot head. So whatever the value in the self dot head will be saved to the next attribute of the new node. Okay, so this way we will be able to do this. Okay, so now self dot head will be replaced with the new node. Got it? Okay, so now I think this should work. So let's say l dot depend, let's say we are prepending 6, and just display this. Okay, and let's say run this. So I think there is some issue. Okay, yeah, I forgot this. So now it is working. Okay, so let me see something. Okay, so it is displaying this one. Okay, so let me do this something like this. Print, let's say, so that you can better understand, because it is printing the same line, right? Oh, sorry, it's a launch. So yeah, it is printing, right? It is prepending the 6 before 1, so it is successful, right? Next, so what if I want to insert something at specific index? Let's say, if suppose I want to call something like this, let's say, okay, let me do something. Okay, here, what if I want to do something like this? L dot insert at particular index. Let's say I want to insert at second index with the value let's say 8. So to achieve this, we need two attributes, index as well as data, right? So here, what if, okay, so we need to prepare the logic for the same. So here we need to get the data inside the new node by doing this node of data. Okay, and soon after we need to specify current is equals to self.head. Let's say here, if I want to insert the data at the specific index, let's say 2, we need to check for while current, no, not while, I think we need to use the for loop. So for in range, let's say in the range of, let's say, index -1 because we need to refer previous node. Okay, so current would be current dot next. So by that way we will get the okay, so previous node of that particular index. Let's say if you are specifying 2, we will get the current index is 1. So the node at index 1. So let's say first index if we got, then we need to change the current dot next to new node, as well as like the new node. Okay, and new node dot next to current dot next current, or whatever the value inside the uh, current next node, it has to be it has to be inserted into the node new node dot next. Okay, so what I mean is, if suppose this is the current node, this is the next attribute, so this is the current dot next, which is referring to C. But if I specify like current dot next, that means it is referring to D, whatever mention at the second place. Okay, so here by this way I think this will work. And yeah, so let us try to, okay, so we also need to display it, right? So display, and let's see what it will be doing. Okay, so what it is doing is, so it is inserting the 8 there, but I think it is directly taking the none after that. So it is not taking this 2 and 3. So why it is not taking this 2 and 3? So that we need to find out, right? Okay, because here we are referring this current dot next, we have changed this, right, with a new node. So I think this has to be the first line and this has to be the next line. So let us try with this. Yes, right. So that was the main issue. But the problem here is, again, there is a problem, right? So what is the problem? Because when we are referring to something like this, because we are prepending and displaying, right? So prepending would be this, right? So whatever we are expecting out of it has to be something like 6, 1, then 8, then 2, and then 3. But this 2 has not been reflected in the output. So what could be the cause of that? So here new node dot next I have changed. Okay, current dot next will be the new node. Current dot next will be the new node, and new node dot next is equals to current dot next. Oh, sorry. So I think we have to mention this current dot next. Okay, so that was the small mistake that I have made. So yeah, now it is showing the correct way, 6, 1, 8, 2, 3. So that's completely fine. Okay, so we have inserted this 8 as specified at the second index, 0, 1, 2. This 8 has been inserted at the specific index with the existing values. Okay, now prepend has been completed, insert has been completed. What if we want to delete something? So for that, let's say I have created a definition, so delete. So inside this, let's say I have mentioned self. What we need at the specific index, if we want to delete the data. Okay, So I think we don't need the data, we just need the specific index. So here whatever the index is, right, so we need to specify current is equals to self dot head. Then we need to iterate a loop till this index minus 1 would be, yeah, because we need to change, because what happens if you want, this is the 0th index node 1 2 and this is the 3rd index node. So if we want to delete the 2nd index node right here, so let's say like the 3rd index node if you want to delete, okay, for an example, we just need to mention this b dot next to the which refers to the D node, okay. So in that way this will be this will not be vanished, but it will not be referenced back, so that we get linked list as A reference to B and B reference to the D, okay. So let me try this. So current is equals to self dot head, and we need to iterate a loop till what, till let's say index minus 1, okay. And what we need to specify here is current is equals to current dot next, okay. So once we get the next, it will be stop at the specific index minus 1. So if suppose we got the B, then we just need to mention current dot next equals to update with the D node. So for that purpose we need to mention something like current dot next. So now by this way, yeah, we are updating this value and we are deleting that specific index node. So let us do something like call this function and see. So delete, let's say at, so here is output, okay. So if I want to delete this set again, so it would be 0 1 2 second index. So second index value I need to delete, and again I need to l dot display, okay. So here let me do this. Oh, what it is saying is not defined, okay. So I think it is okay, yeah, I need to mention the class, right, l dot display, because instantiation we did, right, and if we are not referring that, it would be a problem. So yeah, same way we are able to delete this set at the second index, and we get the 6 1 referring to 2 and the 3. So in this way the linked list will work. So hope you have enjoyed this video. In the next series we will look for the double linked list, okay. Thank you.